Thanks for stopping by to check out this episode of Vintage Audio Review. In this episode, I'm going to talk about this Carver CM-1090 integrated amplifier. Now, this was made around 1992 and sold for around $580, which translates to about $1,200 in today's money. It was rated at 100 watts per channel into 8 ohms, both channels driven at 0.1% THD, and into 4 ohms it was rated at 150 watts per channel at the same THD level. It does have Carver's sonic holography circuitry in it, and it does have a ability to be run by a remote control. Now, this was sent to me by somebody I met on a Facebook forum for Carver Audio. I normally don't have things shipped to me, but the problems he described were things I could help him with, and so here it is, and we'll go through some of its problems and we'll see what is required to repair them. Now, a couple of the things were noisy volume controls, and any of the controls out here that have potentiometers, they're noisy, and the meter lights are out, the lamps are out. He would like those replaced with LEDs. Supposedly it has a problem, or it does have a problem when you use the power on-off switch. Sometimes it goes on, sometimes it doesn't, sometimes it goes off, sometimes it doesn't. So I have that to look at, and he wanted to know if it needed to be recapped, so we'll look at how it does and see if it needs to be recapped. Also, the RCA jack shields in the back, several of them have pulled off and are missing, and I'll show you that in a minute. But anyway, I kind of wanted to get started on this unit, and I'll video what I do to it as things progress in this repair. I wanted to show the rear of the CM-1090, in particular how it is missing some of these RCA grounding shields. Here's your pre-out and main in jacks, and you can see the main in jacks, that grounding shield is no longer present. To be honest, for the purposes that it's being used right here, where you're just using the jumpers, the ground doesn't serve any. If you were to use the main in, you would want that grounding shield there. Also, on one of the CD inputs, it is missing as well. Also, you can tell that we have speaker jacks for 2 sets of speakers. They are banana plug friendly, and you can put a spade in or a wire in. You also have 2 switched outlets and 2 unswitched outlets. So here's the inside of the CM-1090 with the cover removed, obviously. I just wanted to point out what it looks like. So one of the things that I look for are capacitors that are near devices that get hot, like this little capacitor right here is near an emitter resistor, which could get hot if you're running the amp loud. So that typically gets replaced. There's also another one over here. And any of the capacitors that are near output or voltage regulators, like these guys right in here, those typically will get replaced as well. You have a potentiometer for the volume control here, and you can't see the ones for the other tone controls or the balance controls with the front cover on. The other thing is that these input jacks, the RCA input jacks that are missing grounding shields, will need to be replaced. So they'll have to be unsoldered from the bottom. And this board right here is where the lamps are that are burned out. There's one here and one here. And those will be replaced with LEDs. And the adjustments for the pots, I don't really know how you can see it, or the adjustment pots for the power meter display are here and here, and those will be adjusted as well. So this is the bottom of the main circuit board, just showing what it looks like under there. Most of the solder joints look okay, just at a cursory look at them. There is another circuit board for the controls, which is right in this area. There's a board down here. You can't see all of it, but there is a board there as well. So these top 2 RCA jack assemblies are the defective ones that I have removed. They are missing the ground shields here, here, and here. These are the replacement ones, and at first it looks like it might work, and I'm hoping that it will, but there is a difference in that this one's red, that one's white, this one's white, this one's red. And over here, they look like they are the same. There's red there, white here, white here. So here is the view from the back side, and we have a couple problems because the pins don't match. So one thing, when you start looking at the different pins, the ground is right here. This upper one is the ground terminal. Now the ground terminal is underneath. I'm not sure you can see it, but it's on the other side. The other problem is that the left and rights are reversed. So even though the colors matched up, this guy right here is really for the top one right here, whereas this guy right here is for the top one. So these two pins are reversed, and I'm not sure how I'm going to make it all work, but I have the same problem over here, where the pins here, like this guy right here, that pin right there is this guy right here, and he's obviously off the upper one and he's off the lower one. So I'm going to have to figure out how to get it all to work, but I'm sure I will figure it out eventually. I'm not sure how well this will come out, but what I ended up doing was having to cut the ground terminals off. There's 3 of them down here. Once those were off, I made a jumper bar across all the grounds that came across here and made sure that it didn't connect to anything else, and that wire will come out over here and get connected to ground elsewhere. For each of the terminals, I had to cut them off and solder on a wire. So this guy right here comes over and bends over and is going to be right there, and then there's a connection right here, and that wire comes over and connects to here. So I had to reverse all the connections for all of these, and in some cases I used a little bit of shrink tubing for a little bit more protection. It should mount to the circuit board, and there's 2 screws that secure it, so it should work just fine. So I wanted to show the modification that I did for the LEDs. Originally there were 2 incandescent lamps here and here, and they had burned out, and the owner wanted them replaced with LEDs. So I decided the easiest route to go was to put them in parallel, and I did that on a breadboard and measured the amount of current that they drew, which was maybe 10 milliamps for the pair. Figured out the voltage drop from the source, which is 10.3 volts, let's say, and then I determined that a 750 ohm resistor would work. So there is a 750 ohm resistor there. I put it on the negative trace and actually cut the negative trace and then soldered the resistor across the trace more or less, and it seems to work just fine. I will power it on, and it works just fine. It seems to be a good brightness level for the unit, and I will show the actual display when it's all done, but it looks to be a pretty good brightness level for it, and it does have kind of a cool blue glow to the meters now. Our first piece of data is the standard THD SNR plot at 1 kHz with the CM-1090 putting out 5 watts into 8 ohms and the volume control set for 29 dB of gain. As you can tell, the SNR and the THD plus noise is in the 80 dB range, and the THD is a rather low 0.004% or so, so it is looking very good. And here we have the frequency response with the amplifier putting out 5 watts into 8 ohms. And the specification is plus or minus 1 dB, and it looks like we are indeed meeting that. Here we have the THD SNR plot at 1 kHz with the CM-1090 putting out 110 watts into 8 ohms. The specification at this power level was an SNR of at least 90 dB, and we are exceeding that. And the THD was a maximum of 0.1%, and we are far exceeding that. Also, the THD plus noise is greater than 80 dB, which is very good, particularly for a 30-year-old amplifier. Now, the reason that I chose not to replace the filter caps was that the very first spike in the spectrum on the left, that's the 60 Hertz one, that is 120 dB down from the peak, which is very low, and in fact, all the little harmonics at 120, 180 Hertz and so on are below 100 dB down, and replacing filter caps probably would make very little difference to those levels. Here is the result of the multitone test, which shows about 14 bits of distortion-free range. Here we have a plot showing the THD versus frequency at a couple different power levels into 8 ohms for the CM-1090, and for the majority of the frequency band it is beating the 0.1% THD requirement. Here's a plot of the output impedance of the CM-1090, and if I ignore the area below 25 Hertz, the output impedance is about 1.4 ohms, which translates to a damping factor of about 6, which by no means is great. The area below 25 Hertz, I am not sure if there's something going on with the amplifier that's causing the high impedance or if that was just a measurement glitch. Here we have the THD SNR plot with the CM-1090 putting out 5 watts into a 4 ohm load, and here we can see the SNR is about 80 and the THD is still pretty low, and it's looking fairly good. Here we have the frequency response plot with the CM-1090 putting 5 watts out into a 4 ohm load, and it looks pretty much the same as it did when the load was 8 ohms, and it is meeting its plus or minus 1 dB requirement. Here we have the THD SNR plot with the CM-1090 putting out about 130 watts into a 4 ohm load. And this is about the most I was able to get out of this particular integrated amplifier before the THD really jumped. You can see that the right channel is already getting kind of noisy. Overall, though, the SNRs are above 80 and the THD is still better than the specification. However, the THD plus noise on the right channel is right at 60 dB. And the left channel is at 70 dB. If I were to push this up to 140 watts, the THD percent really gets above 1 and the right channel looks really, really bad. Here we have the THD SNR plot at 1 kilohertz for a CD input of 2 volts to the preamp output with the volume set to give 2 volts or set for 0 dB a gain. And we have an SNR that's about 100 dB and the THD is 0.003% and some change, and the THD plus noise is about 90 dB. So this is looking really, really good for a preamp stage. And here we have the frequency response of the CD input to the preamp output with 2 volts going in and 2 volts going out, and it is meeting its plus or minus 1 dB requirement. Here we have the frequency response with the CM-1090 putting out 5 watts into 8 ohm loads, and the CD input is being used and the CD direct mode is being used. So all the tone controls and balance controls are being bypassed. The interesting thing to note is that the frequency response of each channel is better. However, there is a 1 dB or so separation between the two channels, which the owner did not care about looking into because he does not use the CD direct mode. This graph shows the effect of the tone controls as well as the hologram being in the on position. The line in the center, you can kind of just see it as the flat line. It's kind of a blue line. This is measured from the CD input to the preamp output. Here we have the THD SNR plot at 1 kilohertz for the phono input, which is a moving magnet phono input, to the tape monitor output, and it's showing a really good THD, and the SNR is not too bad at all. A little bit shy of the 78 dB SNR specifications at 1 kilohertz. Here is the frequency response of the phono input to the tape monitor output, and the specification was plus or minus 1 dB from 20 hertz to 20 kilohertz, and it is about plus or minus half a dB, so it is meeting that. I forgot to mention on the previous slide that the phono gain was listed at 34 dB plus or minus 2 dB, so we were also meeting that requirement. Here is the back panel with the preamp main-in jacks replaced. You can tell that the red and white are reversed from all the others, but you can just follow the color codes when connecting them. And also you can see that the phono tuner and CD jacks have been replaced as well. Most of the repairs that the owner of the CM-1090 wanted done I was able to install blue LEDs to replace the burned out incandescent lights. And let me turn it on. I think that they are not too bright in a totally dark room, and in a well-lit room they seem bright enough. I was able to clean and lube the potentiometers for the volume and balance. The tone control pots were not really noisy, and they are not something that you can get the cleaner and lube inside very easily at all. They're more of a sealed unit. Also, I replaced the power on-off switch, would be that guy there, and I don't think you can see, that's what it looks like. And it seems to be working fine since that was replaced. What else did I learn? There's a switch called ambience, and in certain CM-1090 manuals it's called surround, and what it does is kind of set up a pseudo surround for the B speakers where it's sending some delays to give you a little bit better of a surround effect, not a Dolby surround, but just a little bit better sound effect if you're using 4 speakers in a single room. Also, the CD direct. Now, there was one piece of data that showed that the CD direct had a flatter frequency response. However, the channel separation was about a dB between the two channels, which isn't desirable, and it's not something you can adjust with the balance control because the CD direct bypasses the balance and the tone controls. Fortunately, the owner of this unit uses the tone controls, and so the CD direct is not something that he would use. I did listen to the CD direct mode versus the flat tone controls and didn't really hear any difference when I just did some listening tests with it. The hologram effect worked rather well in the CM-1090, I thought. As far as listening to the unit, I hooked it up to my KEF 107 speakers, and with the power meters peaking between 30 and 50 watts, and that's into 8 ohms, the 4 ohm KEFs that I was driving provided about 84 to 86 dB SPL, which is pretty loud. When I started cranking on the CM-1090 a bit more, where I was hitting 150 to 200 watt peaks, I did notice some distortion in the right speaker, and that would be kind of expected because we're hitting 200 watt peaks into 4 ohms, and this amplifier did not like to do really well above 130 watt peaks. So I did notice some distortion in the right speaker, which matches up with the right channel distorting more than the left into a 4 ohm load. Other than that, I thought it sounded just fine. It didn't lack anything as far as an amplifier, and I would have no trouble recommending it as a nice integrated amplifier. I thought the phono section measured well. I don't typically listen to phono sections, but it did measure pretty well for a moving magnet input. I did not end up replacing the main filter capacitors on this unit based on the data that I saw, and I'm not a big believer in just replacing caps because they're old. In an earlier part of this video, I did point out a few capacitors that were in an area that would get warm, and so I replaced about 11 of those. I always check them, and half of them were still good, but the main electrolytics seem just fine. So that's my take on the CM-1090 integrated amplifier. Once again, I thank you for taking the time to watch this video, and if you have not subscribed, please do so, and have a great day or night.